Welcome to ClickMyProject.com. Now we are going to discuss about wind turbine gearbox anomaly detection based on adaptive threshold and twin support vector machine. Abstract: data driven condition monitoring reduces downtime of wind turbines and increases the reliability. Wind turbine operation and maintenance cost is a significant factor that calls for automated fault detection system in wind turbines. In this paper, a wind turbine anomaly detection method based on generalized feature extraction is proposed. Firstly, wind turbine attributes are collected from supervisory control and data acquisition system. Finally, the detection model is trained and abnormal state is detected by classifying the result 0. Experiments consist of 3 cases with SCADA data demonstrated the effectiveness of proposed method, and we can able to find the speed of turbine. The earlier fault detection ability of proposed approach was verified on the operational wind turbine. The effectiveness of proposed method is compared with a standard classifier like k nearest neighbor and a random forest. This is our project flow diagram. Our process is going to start with data selection and loading. Data selection means we are going to select a data set for our process. Here we have taken the SCADA data set for the wind turbine prediction, and next one is the data pre-processing. Data pre-processing means cleaning our data set. Here we are going to clean our data set by checking its null values and replacing the null values, and then we are going to do label encoding, that is converting categorical value into numerical value. And then data split. Here we are going to split our data into training set and testing set. Training set is to train our model, testing set is for prediction purpose. And then classification. Here we are going to use two algorithms, machine learning algorithms, that is random forest and k nearest neighbor. And then prediction. After that we are going to give random input, and then we are going to predict the speed of turbine, and then we are going to check the accuracy of both algorithm, and then we are going to check the abnormalities of wind turbine with effective predicted power. Now we are going to see our project output. Our first module is data selection and loading. Here is our sample input data. Our input data contains date time, LV active power, wind speed, theoretical power curve and wind direction. We are going to read our data set by using the pandas library, and then we are going to check our informations of our data by using the info keyword, and then we are going to check count, minimum value, maximum value and mean value and standardized value of our data set. And then we are going to give the comparison graph between our features. It is a comparison graph between frequency and wind speed, and then frequency and wind direction, frequency and LV active power, frequency and theoretical power. And then this is the heat map for our features. And then second module is data pre-processing. Data pre-processing means cleaning our data set. Here we are going to clean our data set by checking its null value. There is no null values in our process. And then third module is data splitting. Here we are going to split our data into training part and testing part. Training part is to train our model, and the testing part is for prediction purpose. Here we are going to split our data with the help of train test split library. And then algorithm implementation. Here we have used two algorithms. One is a KNN and another one is a random forest. These two are machine learning algorithm. First we are going to see about a KNN algorithm. KNN algorithm is one of the simplest form of machine learning algorithm based upon supervised learning technique. KNN algorithm assumes the similarities between the new data and the available data. A KNN algorithm stores all variable of available data and classifies the new data point based upon the similarities. And our KNN algorithm gives the accuracy of 36%. And then a random forest. Random forest is also machine learning which belongs to the supervised learning technique. It is used for both the classification and the regression purpose. It is based upon the ensemble learning, which is a process of combining the multiple classifiers to solve the complex problem, and it improves the performance of the model. And our random forest algorithm gives the accuracy of 98%. It is the comparison graph between two algorithms. Our KNN algorithm gives the less accuracy than our random forest. At last, prediction. Here we are going to give a random input, and then we are going to predict the active power generated in the turbine, and then we are going to check whether power has been generated in turbine or not. For the given input, the power is generated.